this is exercise 7 of 8 for section 5.4. The average math SAT score is 520 with a standard deviation of 111. A particular high school claims that its students have unusually high math SAT scores. A random sample of 40 students from this school was selected, and the mean math SAT score was 553. Is the high school justified in its claim? And then explain. So this one, they actually told us to go ahead and use the z-score. So we're going to look at the z-score for just a minute. And the z-score for this situation, because we're talking about a mean of the students, is x bar minus mu sub x bar all over sigma sub x bar. So we're going to take the mean of the sample minus the population mean of all the students taking that particular SAT across the country, divided by the population standard deviation, divided by the square root of the sample size. Okay, so let's figure out what our z-score is. And I'm going to do it again in 2 steps. And we're going to find the mean math SAT score for those 40 students. And that's 553. Minus the mean of the population, which was 520. Sounds pretty high to me. Enter. Divided by the standard deviation of 111 divided by the square root of 40. And we get a z-score of 1.88. They say 2 decimal places. So is that an unusual? No, that's within 2 standard deviations of the mean, so it's included in the 95% of the population. So I say no, it's not unusually high, so the high school is not justified, because Z is not unusual since it lies within 2 standard deviations of the mean. Good job. Thank you. So let's go ahead and work on the last problem for this section, number 8. And it says the manufacturer claims that the span of its tires' lifespan is 51,000 miles. You work for some consumer protection agency and you're testing the tires. Assume, which we would expect, the lifespan of the tires is normally distributed. You select 100 tires at random. Wasn't that nice? And the mean life span of those tires is 50,888. Assume sigma is 900, and we have 3 parts. So, assuming the manufacturer's claim is correct, what's the probability that the mean of the sample is 50,888 miles or less? So we're going to do a normal CDF. Second, vars, normal CDF, enter. And we want to know that many miles or less, so we're going to start at negative second E99, comma, 50,888, comma, the mean that we're looking at is 51,000, comma, And we're going to use the standard error, which is the standard deviation of the population divided by the square root of the sample size. So 111 divided by the square root of 100, which next time I'm going to divide by 10, since that is the square root of 100, and enter, and we get 0. Well, we see 0 and we get really, really nervous, because where should the probability be 0? Well, that would be if the two means were exactly the same, and they're not. So let me try that again. I'm going to press second entry, because look what I did wrong. Where did the 100 come from? Right there. But where did the 111 come from? I guess the last problem. So it's 900 divided by the square root of 100, and I can press enter from right here, and let's hope this one's right. So it looks better anyway. So we get 0.1067. Check my answer, keep your fingers crossed for me. And we got it right. It didn't hurt us because we caught that one. We would have still had 2 more chances. Okay, so what do you think of this manufacturer's claim? What's the probability? 10% of the time you're going to get that answer. So I'd say we could go back and do a Z. We're going to do it with that. I'd say it's accurate, because the sample mean would not be considered to be unusual, since it lies within the range of a usual event, namely within 2 standard deviations of the mean of the sample means. Whew, good job. One more time. This time it says, would it be unusual for an individual, just one tire, to have a lifespan of 50,888? Why or why not? So we're going to do the same problem. And we're going to press enter. How would this problem change? Well, instead of being a sample size of 100, we're going to be a sample size of 1. But we know that if we take the square root of 1, we get 1. If we divide by 1, we still get 900, and I just erased the whole thing, so let's try that again. Second, vars. Let's just do it this way. Second entry. There it is again. I'm going to try a little harder this time to just get rid of what I want to get rid of, which is everything from the divide by sign on. Enter. So, 45% of the time, we're going to get a probability like that. But the author would probably expect us to do a Z value. So let's try a Z this time. And we get 50,888. That's the individual value minus the population mean, mu, enter, divided by 900, enter, and we get a Z of negative 0.12. Is that within 2 standard deviations of the mean? Yes. So would it be unusual? No. Because that value lies within the range of a usual event, namely within 2 standard deviations. So let's check our answer. We got it 2 different ways. Some students find the Z method clearer than trying to look at the probabilities. And we got, good job. This was the last problem of section 5.4. There will be one more video that's not from section 5.4, but will be on at least one of the tests, so I'd recommend watching that one. More later.